Another classification algorithm that's very popular is called the naive Bayes. We can get that from Bayes folder here. Click on naive Bayes. Now, naive Bayes calculates the prior probability for each class from a training data and assumes that the data is independent of each other. In fact, the naive Bayes is given by this formula, right? So given this equation, we can get the probability of A being true given that B is true. Again, the equation is like this. So the probability of B being true given that A is true as a product of the probability of A being true divided by the probability of being true. Okay. So going back to naive Bayes, I click here just to see that it just has these different configurable parameters. So I'll just leave that as default. And the good thing about naive Bayes is that it supports both binary classification and multi-class classification problems. So let's go ahead and click on start. And you can already see that the accuracy is at 76%. Recall actually slightly improved a little bit. So compared to a random forest, we can say here naive Bayes does a better job, and we can see we've managed to reduce this false negative to 78. Remember, if you're doing diabetes here, you want to make sure that you're able to predict these patients, right? That they have the onset of diabetes, right? It's rather you predict negative. We want to minimize this, right? So we want to minimize this so that we capture all the true positive, the true negatives, and minimize the false negative here. We don't want to, somebody home that has onset of diabetes. So again, this is good, and you can also access the threshold curve here, tested negative. You can see this is what we call the rock curve. The farther it is to the top left, the better the model. So the goal here is to have a 1-1 here. So ROC as well. We can use this, especially when we have an imbalanced data set to compare with other models. Okay, so compared with this, again, you can see slightly the ROC here is much better. And then PRC, we use this especially if we have a highly skewed data set. Okay, so I can see here that comparing these two, you can see the PRC here is much better. But for now, we pay attention to the we'll be paying attention to the false negative. We want to reduce this. So clearly, we want to have our recall to go up. So meaning that we are using precision recall. A good PRC area is one which has the following. So I could actually go here and plot that. X be recall, and then Y will be precision. So the goal here is to have, almost 100% 1-1 here. So a good model is the one that has a high recall and high precision. Okay. All right. So again, we'll the next one we're going to be looking at is called the k-nearest neighbor.